Our second example, taking a look at graphing, finding the degree, we've got a quartic function because it's degree 4. And the shape of a quartic function is a W. The end behavior, because it's negative, our W will be upside down. So it'll look something like this, and it might have a little wave in the middle. Y-intercept, we substitute 0 for x to solve for y. So we get 0 plus 0 minus 81, or the order here is 0, negative 81 for our y-intercept. For our x-intercept, we substitute 0 for g of x and solve for x. So the first thing I noticed, because the lead coefficient is negative, is I'm going to go ahead and factor that negative out. When you're solving, you can even divide everything through by the negative, and then you don't have to worry about the negative sign anymore. All right. This is a T-chart method because the fourth power is twice as big as the second power. Lead coefficient is 1, so we think what multiplies to positive 81 and adds to negative 18. And the answer is negative 9 and negative 9. So we have x squared minus 9 quantity squared. For those that aren't sure where that came from, it would be the same as writing it out twice. Now the x squared minus 9 is a difference of squares, so I can keep factoring. Now remember, I've got the x squared minus 9 twice, so when I factor it, its factors will also be squared. So x plus 3 squared, x minus 3 squared. Thinking about, again, where it came from, this would be x minus 3, x plus 3, and this would as well. So we would see each of those terms twice. Finally, we're going to solve for our zeros. We have zeros of negative 3 and positive 3. And because each of these binomials is squared, each of these zeros has a multiplicity of 2, which means that these are turning points for our graph. So we'll see that when we sketch our graph in a little bit. But we still have a turning point between our zeros because our graph somehow has to get from one zero to the other. So it has to turn somewhere in between those two zeros in order to cross that or to bump the x-axis again. So we're still going to set up our table of values. Finding between our zeros, we're going to have to check negative 2 to positive 2. Substituting these values back into the original function. So thinking in part B here, when we were factoring and we divided out the negative, we have to use the very first function that I gave you way up here. Make sure those negatives are in there, otherwise we will get different values for the function. So substituting negative 2, we get negative 25. Substituting negative 1, I got negative 64. Substituting 0, we already knew that was negative 81, so my function is continuing to decrease. I haven't found my turning point yet. Substituting 1, I get back up to negative 64. So it turns out my y-intercept is my turning point. And finally, we're going to put all of this together in a quick sketch. Now, I know that my x-intercepts were turning points, and I know that my graph opens down, and I didn't get any positive values, so I'm actually going to make my x-axis way up top. Now I need to get down to negative 81, so I'm just going to go ahead and scale it by 9s. And then my x-intercepts were normal, so I'm going to scale my x-axis by 1s. And plot my points. So we first saw that our y-intercept was 0, negative 81. Our x-intercepts were negative 3 and 3. And because those had a multiplicity of 2, they are also turning points. So I knew from part A, when I did a quick sketch of my graph, that it was an upside down W, that my graph will be opening down. So from my turning point here, I'm just going to start heading off. And try and make sure when you hit these turning points that your graph is rounded a little bit. I missed my turning point at 3, graphing that too accurately. It looks like it's off a little bit, so try and be maybe a little bit more accurate when you sketch your turning points. Make sure it's rounded at the turning points. We don't have any sharp curves in our polynomials. And your do try question.